Hello friends, Euclid is a great mathematician and the father of geometry. So let's learn some of the axioms and postulates by Euclid. So Euclid's postulates and common notions, what are these? As you can see, we'll be discussing each and every postulate and each and every axioms. Axioms are also known as common notions. So postulates and common notions. The both are very basic things that actually happen in geometry. So let's read some of one postulate number 5. That is a difficult one. That is, if a straight line falling on two straight lines makes the interior angles on the same side less than the two right angles, the two straight lines, if produced indefinitely, meet on that side on which the angle is less than the two right angles. So this is what is the postulate number 5. But were you able to understand? No. So let's begin with postulate number 1. A straight line may be drawn from any point to any other point, right? It could be drawn from any point to any other point. Quite common. Next, we have postulate number the 2nd. A terminated line can be produced indefinitely. You can produce it indefinitely, right? If you stop making the line, you can produce it indefinitely till the end of the sheet. Postulate number 3. A circle can be drawn with any center and any radius. You can take any center and any radius while drawing a circle. There's no hard and fast rule. Postulate number 4 says that all right angles are equal to one another. The most basic. All right angles equal to one another. All right angles are 90 and 90 is equal to 90. It's quite common. Postulate number 5 that says if a straight line falling on two straight lines makes interior angles on the same side of it taken together less than the two right angles, then the two straight lines, if produced indefinitely, meet on that side on the which the sum of the angles is less than the two right angles. In the given diagram, sum of angle 1 and angle 2 is less than 180 degree. So lines L and M will meet on the side of angle 1 and angle 2. So this is what this postulate says, that the wherever it is less than 180, the angles, the lines will meet there. M and N, the meeting that side, right? So this is one of the most common examples in the best way you can understand this postulate. And in simple words, we can say that for every line L and for every point P not lying on N, there exists a unique line M passing through F parallel to N, right? So this is all that you can actually get. So the previous line that I said was Euclid's fifth postulate as per John Playfair. He just described it in some other manners. So now we would be moving ahead. Talking about, yes, so let's move ahead now to the Euclid. Another rule, that is a Euclid's division lemma algorithm. So first of all, what is the steps? Step 1 says that apply Euclid's division lemma to C and D. So we find whole numbers given R such that C is equal to DQ plus R, where 0 should be less than or equal to R and R should be less than D. This is actually the formula for division lemma, how you can actually apply this. C is equal to number, right? So, and DQ plus R, we need to fill them with real numbers. Step 2 is if R is equal to 0, is the CF of C and D. If R is not equal to, apply the division lemma to D and R. Continue the process till the remainder is 0. The divisor at this stage will be the required SCF. So R stands for the remainder. So now let's move ahead and now we'll just see an example. Question says that find the HCF of the integers 455 and 42. We start with the larger integer, that is 455. Then we use Euclid's lemma to get 455 is equal to 42 into 10. 420 plus 35, 455. Now consider divisor 42 and the remainder 35 and apply the division lemma to get 42 is equal to 35 into 1 plus 7. Now consider division 35 and the remainder 7 and apply the division lemma to get 35 equals 7 into 5 plus 0. Now we can see that R, that is our remainder, has become 0 and we cannot proceed any further. So can we claim that HCF of 455 and 42 is the divisor? That is 7. Yes, 7. So this is one of the most easiest way you can find the HCF of integers using Euclid's division algorithm. So that was all